Hand wash timer. Aim to make a hand wash timer where the IR sensor detects a person's hand. When someone arrives, the LED turns off. And when no one is there, the LED stays on. Components used: IR sensor, BC547 transistor, LED, 220 ohms resistor, breadboard. Connecting wires, 9V battery. Component explanation. 1. IR sensor, a sensor that uses invisible infrared light to detect if something is near. It sends infrared light out and checks if it comes back. When a hand comes close, the sensor output changes. Pin out, VCC positive, GND negative, out signal pin that tells if someone is near. 2. BC547 transistor, a small electronic switch that turns the LED on or off. A small current at the base controls a bigger current between collector and emitter. Pin out, flat face toward you, left collector, middle base, right emitter. 3. LED, a small light that glows when electricity passes through it. Pin out, long leg positive, short leg negative. 4. 220 ohms resistor, controls and limits the electrical current. Used so the LED does not burn due to extra current. Pin out, no positive or negative. 5. Breadboard, the connection board used to connect parts easily. 6. Connecting wires, they join all components together. 7. 9V battery, the power source for the circuit. Pin out, plus, positive, negative, connections. Step 1. Connect two 220 ohms resistors in parallel. To drop the voltage of 9V battery to 5V. IR sensor works smoothly at 5V. Step 2. Place the BC547 transistor on the breadboard. The transistor will act as a switch to control the LED. Step 3. Connect the IR sensor VCC pin to the common point connection of two resistors in parallel. The sensor needs positive power to work. Step 4. Connect the IR sensor GND pin to the negative line of the breadboard. The sensor must return current to the battery to complete its own circuit. Step 5. Connect the IR sensor out pin to the base of the BC547 transistor. The sensor's signal controls the transistor. Step 6. Connect the emitter of the BC547 transistor to the negative line of the breadboard. The emitter must go to ground so the transistor can switch properly. Step 7. Place the LED on the breadboard. Connect the short leg, negative, to the collector of the BC547. The transistor will pull this point to ground to control whether the LED is on or off. Step 8. Connect the long leg, positive, of the LED to one end of a 220 ohms resistor. The resistor protects the LED from high current. Step 9. Connect the free end of the 220 ohms resistor to the positive line of the breadboard. The LED gets power through the resistor. Result: when no one is near the IR sensor, LED stays on. When someone brings their hands near the IR sensor, the sensor detects the hand, sends a signal to the transistor, and the LED turns off. This shows that someone is washing their hands. Precautions: always connect the battery at the end. Do not touch bare wires together. Keep all components fixed tightly in the breadboard. Do not shine strong sunlight directly on the IR sensor. Check all positive and negative connections before testing. Conclusion: this was our hand wash timer project. By using an IR sensor, a BC547 transistor, a resistor, and an LED, we made a simple system that shows when a person is washing hands. The LED turns off when someone comes near and remains on when no one is there. This project helps in learning about sensors, switching, and hygiene automation.